Did you hear about the quadrilateral that wanted to be a parallelogram? Unfortunately, his opposite angles were not up to par. Do you get it? Par, parallelogram? Not very funny? That's okay. All right, but we are talking now about quadrilaterals that want to be parallelograms. Can they join the Parallelogram Club? And we're going to be using the properties we learned in 6-2 for this section, 6-3. The good news is to show that a quadrilateral is a parallelogram, you only have to show that it satisfies one of these sets of conditions. So you're going to want to keep this page with you as we go through the other problems. First of all, so just one is good enough. You can have two pairs of opposite sides are parallel, and that's the definition of a parallelogram. So you can just say definition. You can also say one pair of opposite sides is parallel and congruent. So I'm not showing that the two opposite pairs are parallel. I'm just focusing on one set of parallel sides. And if they're parallel and congruent, that's good enough. Or I can say both pairs of opposite sides are congruent. If all the opposite sides are congruent, remember that was one of the conditions or properties we learned in the last lesson. And then you can also use if one angle is supplementary to both of its adjacent angles, then that is a parallelogram. And finally, if the diagonals bisect each other, that is a parallelogram. So let's go ahead and look at these quadrilaterals in example 1. And I have to determine if each quadrilateral must be a parallelogram. So first of all, looking at this first one looks kind of promising. If I look at 63 and 17, yeah, those do add up to 180. These are supplementary. But let's say I take the 117. Not only does it have to be supplementary to this angle, it also has to be supplementary to this angle. Now you could say, well, it looks like it, but you don't know for sure. What if I just pulled this angle in by a few degrees and that was 60 degrees? Then that is not a parallelogram. So unless you know this angle for sure, you cannot say that that is a parallelogram. So the answer is no. We know that the angle is supplementary to only one of its angles, but we don't know about the second one. Now let's take a look at this one right here. I've got 57 degrees, 123 degrees, 57, 123. Well, these are linear pairs. And let's see, could I change this shape without changing those angles? Sure. I could put a point right there and connect it. Whoops, pretend that's a straight line. All right. Is that a parallelogram anymore? No, it's not. And the reason I can do that is these angles, when you have two diagonals crossing, they're always supplementary because they form a straight line. And vertical angles are always congruent, no matter the shape. So this is not very helpful in determining if that's a parallelogram. Now, last but not least, I'm looking at two diagonals. And I can see that the 78 and the 78, so these two segments right here are congruent. And then I have the 102 and 102. So I have two diagonals that bisect each other. Well, yes, I can say this is a diagonal. All I need to say is that the diagonals bisect each other. Now let's take a look at example 2, which is a two-column proof. And what we're looking at is we have AB here is congruent to CD. So they gave you that one. They had the marks on it. They also told you BC is congruent to DA. So we're going to prove that if you have two sets of congruent sides, then you must have a parallelogram. Well, we have the given part. That's the easy part. And then they say, BD is congruent to BD. So the segment is congruent to itself. When the segment is congruent to itself, that's called the reflexive property of congruence. Now I have, let's see, BA and CD, and then AD and CB, and then BD to DB. Well, I can actually say these two triangles are congruent. So DAB is congruent to BCD by side, side, side. So that's the side, side, side postulate. Now I can start marking some angles congruent. I can say angle 1 is congruent to angle 3. Why can I say that? It's the corresponding parts of congruent triangles are congruent. That's CPCTC. So angle 1 is actually congruent to angle 3. Angle 4 is congruent to angle 2. Also, by CPCTC, corresponding parts of congruent triangles are congruent. Well, now they're trying to say that AB is parallel, AB is parallel to CD, and they're trying to say that BC is parallel to DA. Well, how can they do that? Well, if you look at AB to DC, you can look at angles 1 and 3. Those are alternate interior angles. So if my alternate interior angles are congruent, then my lines are parallel. And the same thing goes for the other set of lines. So since I use congruent angles to show parallel, that's called the converse. I went backwards in the original alternate interior angle theorem. So it's the converse of alternate interior angles. Well, okay, I have two sets of parallel sides. I just showed that. And if I have two sets of parallel sides, that actually goes back to the definition of the parallelogram. Okay, example 3, and don't be surprised to see some problems where they just say, oh, here are the coordinates, and tell me if this is a parallelogram or not. There are a couple different approaches you can use. When I have coordinates, the easiest thing for me to find is slope. I can also find distances, but that's a lot more work. So let me first of all do the slopes, and it wouldn't hurt to graph it, but I didn't do it here. So I have E is -1, 5, F is 2, 4, G is 0, -3, and H is -3, -2. I'm going to do slopes to show lines are parallel. So I'm going to look at EF and GH first. Well, I went ahead and calculated the slopes using slope equals y2 minus y1 over x2 minus x1. For both segments, I got the same slope, -1/3. Well, if I get the same slope, then those two segments are parallel. And let me go ahead and look at the slopes for the next set, because remember, parallelograms always go in order, and I don't know that they're actually oriented like this. So I showed that EF is parallel to GH. Don't worry that I went in one line to the other. Now I'm going to work on FG and see if I can show that that's parallel to EH. So I did HE, found the slope, and I got 7/2. I did FG, and I found the slope is 7/2. Well, that means that those two are parallel. Well, by the definition of a parallelogram, if you have opposite sides are parallel, then it is the quadrilateral is a parallelogram. Now in example 4, we're looking at to see if this is a parallelogram or not. Well, I have two angles here and two angles here, and you can see they're congruent. Well, believe it or not, the third angle, if I can draw it in, will also be congruent. This is called the third angle theorem. So the third angles in both triangles are congruent by third angle theorem, right? So, because like say I had 60 and 80, then they add up to 140. My only other answer would be 40. I don't have numbers in this problem, but that's kind of how that third angle theorem works. Well, then I have the opposite obtuse angles are congruent. Do you see that? If I take a highlighter, let me get a highlighter. And actually there are different ways to approach this problem. This is the way I approached it, but you could have approached this different ways. So I said, aha, look, that angle there and that angle there have to be congruent because they're the sum of the same size angles. And since we have opposite angles congruent here and opposite angles congruent on the other, both pairs of opposite angles are congruent, so it is a parallelogram. Now I'm going to show, this is a pretty simple problem. I just need to show that it's a parallelogram. And don't forget we have all those conditions for showing that. Well, they gave me a lot of information, so I'm going to guess it has something to do with the fact that diagonals of parallelograms bisect each other. So let's go ahead and find the values. I'm going to first look for JN and NL. I just substituted 4 in for A, and for JN I got 7 times 4 minus 6, or 22. For NL, I have 5 times 4 plus 2 is 22. So I can see that this is actually bisected, that those two segments are congruent. So that's a good start. Now on the next one, let me go ahead and mark those congruent while I'm thinking about it. So those two are congruent. I'm going to look at the other two segments on the other diagonal. So I calculate the length of those, and I find out they're both 10. So these two segments are congruent. Well, if the diagonals bisect each other, then it is a parallelogram, at least for quadrilaterals. Last but not least, example 6. This is I'm sure you've seen questions like this a lot on your test. What additional information would allow you to conclude that this is a parallelogram? Now you can see that you have XW and YZ. First of all, they gave you these angles right here. Those are congruent. Now I don't know if you see this transversal here. Those are alternate interior angles. So by the converse of the alternate interior angle theorem, XW is actually parallel to YZ. So we know that. XW is parallel to YZ. All right? So we know that's true for the whole problem. Now I'm going to go ahead and take a look at each of the answer choices to see if they give me enough information. Answer choice A says XY is congruent to ZW. Well, we have a pair of opposite sides congruent, but that doesn't necessarily make them parallel. I could have, for example, an isosceles trapezoid. So I could say, oh, those opposite sides are congruent. See, these are parallel. That would work, but I'm not trying to show it's a trapezoid. I'm trying to show that it's a parallelogram. Let's take a look at B. Well, it's saying that WX is congruent to YZ. Well, that would give us a pair of opposite sides that are parallel and congruent. That looks pretty good based on what we had on the front page, but let's check the rest. For C, we have two congruent diagonals, but guess what? On an isosceles trapezoid, the diagonals are congruent there too. So I would not say it was C, and I would not say it's A, so we can cross those off, right? Then last but not least, then they tell us that two angles are congruent, X, W, Y, and Z, Y, W. Well, that would pretty much tell me those lines are parallel. Doesn't give me any extra information, so that's not what I'm looking for. So that tells me that the answer is B. B is our correct answer. And you can see I highlighted it there.